Hi, hello everyone. Welcome to this week of GDSC. As the poll suggested, you're all very, very interested in machine learning and TensorFlow. So that is what we've put together a session this week on for you. So this is machine learning and TensorFlow, being lazy and making machines do things and think for us. So next slide, please, Sam. So over the next 2 hours, we're going to be getting progressively closer to being the most lazy we can possibly be. So we're going to cover over what is AI, what is CI, what is ML, what is DL. We're going to use ML to do things, and then we're going to have a practical using TensorFlow. Next slide, please. So first things first, a short Kahoot. Everyone loves Kahoots. Classic mode. There you go, and it should. Hey. For anyone watching online, the game pin is 9156684. Give people a minute or two to join still. Does anyone else want to join? That's a really good nickname. All right, cool. Is that everyone? Anyone else want to join? Sam, you should join. Pardon? Oh, you are joining. That's also a very good nickname. All right, cool. With 8 people, anyone else online? I'm giving you like 10 seconds to join now. Oh, Luke at home. There we go. All right, cool. 10 seconds. 9, 8. Oh, Luke from home left. Should we give him a minute to rejoin? He's not at home anymore, no. There we go, he's back. All right, Sam, start it before Luke at home can escape. So, see, it's Kahoot at home. So this is the GDSC UOP AI quiz. So for first question, what does AI stand for? That's pretty good. I'm glad that you know what a basic acronym means. Congratulations. All right, next question, please, Sam. Just in the top right. And in first place is Emre. Congratulations, Emre, for being quick. All right, next question. So this is a true and false question. Are machine learning and deep learning the same thing? This quiz gets progressively harder. Yeah, exponentially. Okay, so yeah, the majority of you got it right. We'll cover this later in the session today. Machine learning and deep learning, whilst being similar, are not quite the same thing. Deep learning is a subset of machine learning. It's more specific. All right, Sam, next slide. Next slide. Emre. So now we've got Aaron in first place. Well done. Next, please. So which of the following are machine learning models? It's a multiple choice. You can pick as many or as few as you want.
It's not multiple choice.
Isn't it?
They're all right. Yay.
Well, I messed that up, but yep, they're all right. So clearly I am bad at setting these up, but that's relevant. They were all right. They're all different machine learning models, and we're going to go over some of these a bit later today. All right, next question, Sam. My heart. So, which British computer scientist invented a test to determine if something is an AI or not? So there we go, the majority of you got it right. It is Alan Turing, it's the Turing test. We'll talk a bit more about Alan Turing later. Alan Turing was instrumental to sort of the foundations of building up what we now know as today's AI. Yeah, it was the Turing test. So next, please. And we've still got #1 Google fan ahead, having a very good streak, congratulations. So, what is an artificial neural network? So there we go. So we've got 4 out of 9 of you getting it right. That's, again, pretty impressive. So a neural network is a computing system inspired by the brain's neural circuits. Now, a multi-layer perceptron, that is a form of neural network, and pattern matching and classification is something that we can do with neural networks. We'll talk more about neural networks later, but the definition sort of from the Merriam-Webster dictionary is a computing system inspired by the brain's neural circuits. And that's why we call it an artificial neural network, because in your brain, that's called a biological neural network. Next slide, please. He's running ahead. So, this is what I would say is quite a mean question. It's why I put an image up. Who invented convolutional neural networks? I put a picture of him there. Doesn't help, but there you go. So that was Jan LeCun. He was the person who invented convolutional neural networks. So Eric Schmidt was the ex-CEO of Google. Sergey Brin was one of the founders of Google, and it was obviously not Mark Zuckerberg as the CEO of Facebook. Jan LeCun was instrumental to. He now is head of, I believe he's head of research at Facebook now. But yeah, he was instrumental to building up convolutional neural networks, which are used a lot in in AI over video and stuff like that. Next, please, Sam. And congratulations to 2 of you got it right, though. All right, so another true or false. Has an AI ever beaten a chess grandmaster? There we go. So, okay, clearly all of you know that is in fact true. So moving on to the next question. Oh, Aaron's just ahead, well done. So next question, we all know that is true. What was the name of that AI that beat the chess grandmaster? I believe it was Garry Kasparov. Well done to whoever got that right. Deep Blue was the AI that beat the chess grandmaster back in, I believe it was the very late 90s. AlphaGo is another AI, and we'll talk about that again later. That is the one that was developed by Google DeepMind, and that's the one that beat the Go grandmaster about 3 or 4 years ago. So then, I believe that is. We hit next. Oh no, we've got one more question. Oh, there we go. We're going to be talking about TensorFlow quite a lot today. Who made TensorFlow? Again, impressed. So yeah, so that will be the end of our lovely Kahoot. So here's our podium. In 3rd place is Elle. Congratulations. In 2nd place, Aaron. Oh, that means that. Oh, if you could squiggle the mouse, or is it gone dark reason? #1 Google fan. Who's that? Well done, Alvy. I don't have any prizes, but there we go. You're in the podium, and that's all that matters. All right, Sam, would you mind closing the tab? And so that was our Kahoot. So now we're going to start our actual session. So next slide, please. So we're talking today about artificial intelligence, machine learning, deep learning. So artificial intelligence, it's a branch of computer science, And the main focus of it is the simulation of intelligent behavior. So that's taking data and doing something marginally correct from that. Next slide, please. So that includes, as I mentioned before, machine learning, computer vision, fuzzy logic. There's a large number of subsets of.
What is fuzzy logic?
So fuzzy logic. Oh God, I've just got 95% of the course with this. I should be able to explain it. Fuzzy logic is it's a way of determining, a way of showing non-certainty. So let's say you have a set of values, and those values go from 0 to 100. In a what's called a crisp context, you would say that the 0 value is the only value that is 0, and the rest of them are not 0. In a fuzzy context, you would say that the 0 has a membership value to the set of values that are equal to 0 of 1. The number 100 has a value of 0, and there'll be like a slope going from 0 to 100. I can't explain it all right now, but it's a really interesting area, and it comes under artificial intelligence, which today people have started not using the term artificial intelligence just because of how much it's been used in like pop culture and how much misunderstanding there is in it, and that the term now that's mostly used is computational intelligence, but AI just sounds better personally. So we can go to the next slide, please, Sam. And so the AI's got many use cases, including but not limited to behavior prediction, cybersecurity, advertising, smart homes, and most recently, AI and machine learning have been used a lot to help combat the spread of COVID-19. And so if we go to the next slide, you can think of AI as or CI, as this very large topic area, and we're going to delve deeper into it. So the first area that we're going to delve into, and the topic of today's session, is machine learning. Sam? So machine learning, or non-programmed programs, as some people call it, is the study of self-improving algorithms that use data and their own experience to get better over time. Next slide, please. So models using machine learning, they're built on sample data, which is used to then train wanted behavior through essentially telling the model if it's right or not. Next slide. And so it's logic-based. It tends to use probability and sort of relations within the data to come to conclusions. So in a training data of birds, if 100% of the birds are going to be red, a machine learning model is probably going to predict that all birds are going to be red. And so it's really dependent on that training data. And we'll talk more about that later when we're actually doing the practical side of this session. Next slide, please. And so machine learning, as I said, is a subset of AI. And so we'll put it there. Next slide, please. And so deep learning, everyone loves the term deep learning because it's honestly very interesting. It's to do with psychology and sort of brain activity. So it's a subset of a brain of machine learning implementing artificial neural networks. We'll talk a lot more about artificial neural networks later, what they are, what they're used for, sort of some of the types of neural networks. Next slide, please. Neural networks use multiple layers of computation to come to a solution. So like in our brain, there are these things called neurons or artificial neurons. And these artificial neurons are basically used they ping data back and forth with each other through processes called propagation and feed-forward propagation and backpropagation. And we'll talk more about them later. Next slide, please. And so they've been used for much more complex programs than standard machine learning. So in our birds example, in our set of 100 birds, so in our set of birds where 100% of them are red, a machine learning model might pick out the red, and pick out if all the birds, like it might say that, I don't know, robins are red, and all of these birds are red, therefore all the red birds are robins. And a more typical and simple machine learning model might do something like that. Neural networks tend to be a lot smarter, and sort of deep learning, however, due to this, is also much more difficult to program and takes a lot more computational power. Next slide. And so as I said, deep learning is a subset of machine learning, so we'll put it at the very bottom of our AI Venn diagram circle thingy. All right, so next. So before we go into the more theoretical and practical side of AI, I just wanted to give you a little bit of a history on artificial intelligence, machine learning, and deep learning. Next slide, please. So the very foundations of theoretical computer science, and this is what artificial intelligence is all built on, theoretical computer science, came about roughly in the 1930s. And it was described by Alan Turing, who was a British cryptographer, computer scientist, worked out of Bletchley Park. It's near Milton Keynes. If you've been there, very, very cool museum. I would highly recommend you go there. Next slide, please. So the Turing machine is a computational model, and it describes an abstract machine. So it's sort of an abstraction of what is computable, in essence. Next slide, please. And so this is the theoretical basis for an artificial system that later computer scientists would then go on to use, and by later I mean about 5-10 years later, would use this basis of a theoretical machine to think, well, if we can develop anything theoretically through this, what can we do to make machines smarter? And that's where the whole field of AI came from, and it really blossomed in the 40s and 50s and definitely into the 60s and 70s. Next slide, please. So Turing predicted that one day an AI would be like an artificial system, because the term AI wasn't about then. The term AI came about in about the 50s, would be able to beat a human at chess. And he was correct, it happened about 70 years later. So next, so the first real AI application that was ever developed was actually developed again here in the UK. It was developed by a computer scientist called Christopher Strackley at the University of Manchester. Next slide, please. It was a basic sort of game playing model. Christopher Strackley also developed, whilst doing this, what can be argued as the first video game, which was this game of checkers. And by 1952, this intelligent system could play a full game of checkers. It was a lot slower than a normal human would be at playing checkers, because they didn't really have the computational power at the time, but it could do it in what was defined as a reasonable time. I'm not quite sure exactly how long it took, but there you have it. Next slide. And Strackley published the first, what was called a machine learning paper, that same year in 1952, focusing on that game of checkers. And that's really where the sort of the academia of machine learning and AI really started, from 1952. So next slide. So those are the two sort of founding moments of AI, but there's been a lot more. So in 1943, so there's just some important milestones, there's a lot of them. 1943, the first artificial neural network was sort of theorized about. This was purely a mathematical basis at the core of it. It wouldn't be computed until it was in like the 70s and the 80s. It would be actually computed when we had computational power to do it. In 1948, the first what are called autonomous robots. These weren't smart robots like we would think of today. These were purely sort of, the robot has a sensor, it senses light, it goes to the light. But it was a breakthrough because it was the first time that any machine or robot could do something without direct human contact, and it could sort of change its strategy midway through operation. 1955 is when the term AI itself was actually coined, and this was by John McCarthy, who was an American computer scientist for the Department of Defense. He would then go on to Dartmouth College, which is in, I think, Connecticut. He went on to found the first artificial intelligence conference. Shortly after that, about 10 years later, the first real applications of AI started seeping into the world. You had the first chatbot in 1964. The mathematical model of backpropagation was invented in 1969. Then in 1970, very shortly afterwards, you had the first of what are called intelligent robots, and these are robots kind of the predecessors of what we have today, so actually smart. By the late 70s, you had voice-connected technology, and by the 80s, AI began to be put into commercial products at a very sort of low level. Next slide, please. So on to later. By 1989, AI had really boomed. So you had companies like IBM and sort of the early pioneers of sort of what we today call the tech industry were really coming out. In the late 80s, you had the Deep Blue beats its first chess master in the late 80s. By 1996, it beat Garry Kasparov, who was the world champion. By the late 1990s, machine learning had pretty much gone into every industry in the world. This is when you had your sort of boom of sort of the web and also of like data analytics as an industry and data science really booming off. Then by the late 2010s, IBM Watson, which was the successor to Deep Blue, it wins Jeopardy, and then into what is around now. The big AI company is Google's DeepMind, and DeepMind has a product called its Alpha series, and you have AlphaGo, which beat Lee Sedol at Go in 2016, who was the Go Grandmaster, and that was a really sort of pivotal moment because Go is an exceptionally complex game with millions, I believe actually billions of possible moves. And then in 2019, AlphaStar, which was their current product, I'm not sure if any of you watched it live. I watched this live happen. beat pretty much all but the very best StarCraft players. And that's sort of where we are with AI right now, is that AI is getting to a point where in specific remits where it's trained well, can outperform humans. And sort of looking into the future, the next sort of big revolution in AI is when a general purpose AI can outperform humans at everything. And that's probably going to be within the next 20 to 50 years. So next slide, please. So now that we've gone over sort of a brief history of AI, we're going to focus more onto machine learning, because that's what this lecture, this talk is actually about. So we're going to go over some machine learning models, only some of the more simplistic ones, and we're not going to go really deep into the theory. We're just going to go over sort of what the models at like a very high level do. So the first slide. So the first one I'm going over is, I'll step to the side so you can see this, is a decision tree. All of you are second year or above, right? Yeah. No? Okay, so you haven't done data structure and algorithms yet, but you'll do that next year. So this is a tree structure, and that's where you have nodes, and those nodes have branches that go to different nodes. The decision tree is essentially one of those, where at each node a decision is made based on input data. So this is the survival of passengers on the Titanic. So you can see that first it checks the gender. If they're female, it'll predict they survived due to the fact that most women on the Titanic survived, and if they're male, it'll go down a subtree and decide what the chance of them surviving or dying is. Next slide, please, Sam. So each leaf node at the bottom, these are survived or died, represents a result or an outcome of the model. Next slide, please. And algorithms using these, and I'm not going to go over these now, but feel free to take a picture of this or whatever and go and look into them. These are the algorithms used in decision tree. There's ID3, C4.5, which is an upgraded version of ID3, CART, CHADE, and Mars. Next slide, please. So another really sort of basic machine learning model is a support vector machine. And essentially what this does is you have all of your data points, and you're going to graph them in a 3D, 4D, 5D, whichever dimensional space you need to separate them. And in between these, you're going to draw a massive, what's called a hyperplane. And these hyperplanes are there to divide the data up into the classes or the regression or whatever you want. And next slide, please, Sam. And so the distance from the plane to each data point, which is known as a margin in an SVM, which is your Euclidean distance, so that's your Pythagorean distance, denotes the confidence level. So if something's very far away on one side of the hyperplane, there's a really high chance that it's part of that. If it's very close to the margin, very low margin, very close to the hyperplane, we're not 100% sure about it, but we think it's probably on that side. Next slide, please. So data is mapped into y dimensions until a dividing hyperplane can be found. And so that dividing hyperplane, as I said, as we can see in this image, in a two-dimensional space, you can't really divide those. In a three-dimensional space, you can split them down that hyperplane. And in more complex data, you go into 4 dimensions, 5 dimensions. I've seen examples of support vector machines where about 300 dimensions. They're a bit over the top. But yeah, so that's a support vector machine. Next slide, please, Sam. And so the third and final basic machine learning model I'm going to go over is the K nearest neighbors, or KNN. And so KNN is essentially, you map the data on 2 dimensions. It's a bit more simple than a support vector machine. And you map data on a 2D plane, and each value with a known class will have that class marked. So you can see we have these classes here. So we have a class triangle and class circle. And these are those. And then next slide, please, Sam. And then, so a value of an unknown class can be mapped onto the plane at its data point, so the green one here. And depending on which K value you're using, so you can use 2 nearest neighbors, 3 nearest neighbors, 4 nearest neighbors, etc. And so in this case, at 3 nearest neighbors, we can see that we have 2 triangles and 1 circle. So with 3 nearest neighbors, we would classify this green point as a triangle. But with 5 nearest neighbors, there are actually more red circles than blue triangles, so we would classify it as a circle. So next slide, please. And so the class is determined by a majority vote, so you figure out how many in the sort of the minimum circle for that value K, and then you count how many data points are in there, and then, yeah, you do a majority vote. So next slide, please, Sam. So we have some other machine learning models that you can go over. There's tons of them. A lot of them are really interesting. Go and do some research. I really would suggest you do. So there's random forest, and that's called an ensemble method. Essentially, when you get lots of small instances of a machine learning method and sort of majority vote them together. In the case of a random forest, we take lots and lots of decision trees. So decision tree might have the same result only about 50% of the time. Or less even, most likely. And so we would majority vote it with however many trees in the forest. And you might say, oh no, I have 20 decision trees, I'm going to majority vote it. And you'd get the one that comes up most and say, okay, this is the what we're going to do. There's also naive Bayes, which is, if you're into statistics, this is a probabilistic classification based on Bayes' theorem. Anyone have a guess or know what Bayes' theorem is? No. So Bayes' theorem is a core part of statistics. It's pardon me. It's essentially saying it's probability based on I believe it's independent change, and so you can say the probability of X given Y. That's Bayes' theorem, and so a naive Bayes will say, okay, what our outcome is going to be. Let's say we have all of these variables. We'll do a statistical model and work out what the probability of this based on that is. And we'll build a Bayes equation for that, and then that'll be our output. And as we've mentioned before, there's artificial neural networks, which are more commonly associated with deep learning, which is a subset of machine learning, and artificial neural networks are sort of the overarching thing for a number of models, leading from perceptrons, multi-layer perceptrons, which is what we would consider a basic neural network, and I'll talk a bit more about them later. And we got convolutional neural networks, adversarial general networks, the list goes on. But yeah, there's a lot of different forms of neural networks. We're gonna cover just the basic ones today, which are multi-layer perceptrons. But I would highly recommend, if you're interested, to go look into them, because they all have their own use cases and they're all used for a different thing. Next slide, please. So TensorFlow, the second part of this talk is on the Google Technologies TensorFlow. So next, please. So TensorFlow is defined as end-to-end machine learning. We're actually going to be using it for deep learning today, but as I said, deep learning is a part of machine learning. So it's an open source machine learning and AI library. Next slide. It was developed by Google Brain back in 2015, so it's on, I think we're on TensorFlow 2 or 3 now. But yep, next slide, please. It can be used, many languages have the TensorFlow library, but we're going to focus on, next slide, please. We're going to be focusing on Python, because I know a lot of you will have learned Python or will be learning Python in first year, and so it's a good core language for us to use. So next slide, please. So great. What can we do with TensorFlow? So next slide, please. So we could go and we could have a look at videos and we could try and pick out cars. This is a really hot topic now, right now, with like Tesla, with their collision detection system, maybe not working as well as it probably should. Next slide, please. You can also use voice recognition, like in an Amazon Alexa. I don't think Alexa specifically uses TensorFlow, but Google Home definitely does. And so you can also plug TensorFlow models into Amazon Alexa to build your own voice recognition apps. You can also just do it on your own laptop. Next slide, please. Another use, and this is a little bit of foreshadowing, we can do some image recognition. So this, we could try and figure out what this is. And that's something we'll find out in a minute. So next slide, please. So let's all install TensorFlow. So if you've got your laptops or your computers out, we're going to go over how to install TensorFlow. So next slide, please. So we'll be using Python. So give you a few minutes. I think the rest of the session is going to be pretty much practical and us walking around time. So I think we end the stream now. Okay. Cool. Thank you everyone who's watched online. I will shortly put a link to a tutorial from tensorflow.org into the chat on the Discord. That's what we're going to be following along with here. So yeah, thank you very much for coming to the first set.
I'll make sure that link is in the description of the YouTube.
And yeah, the link to the link will be in the description. All right. Thank you so much, everyone.